electric potential at a point due to the point charge. Electric potential of a point charge at a distance r. This is a derivation, proving of formula. This q charge is at infinity, and work done from taken a positive charge from infinity to the external field to the point of source or in the to that point is known as the electric potential. So this is the q charge at infinity, and this q charge and this q charge opposes. So thus the force by the system will be here, and we have to taken a charge from infinity to the point, so we have to done external force required is at this side, and the distance moved is dx. So then the formula of force, Coulomb force, is 1 upon 4 pi epsilon naught q into q by distance is x square. Work done is equal to force into displacement, and the force is f vector and displacement in dx vectors. Differential work done 1 upon 4 pi epsilon naught qx q into q upon x square is a minus dx, because this dx is in negative direction, negative x-axis, or we'll be saying that opposite direction, minus dx. Then this integration 1 dw is equal to minus 1 upon 4 pi epsilon naught q into q x की power minus 2 dx. Limit tends to infinity. Charge is taken from infinity to the point r distance, so limit is infinity to r. Work done is equal to minus 1 upon 4 pi epsilon naught q into q minus का 1 upon x integration by power rule x की power n plus 1 upon n plus 1, so minus 1 upon x infinity to r. W is equal to q into q 4 pi epsilon naught r. 1 upon r is equal to potential energy. This is the formula of potential energy, and electric potential is W upon q. So W is this divided by q, then we get a formula V is equal to 1 upon 4 pi epsilon naught q by r. So formula V is equal to 1 upon 4 pi epsilon naught q by r, and this is the proving of electric potential.